All right, so we're going part 2. We did molar mass the other day. Now we need to use the molar mass to convert from grams to moles and moles to grams. And this will be an important part. While you can look up some of the molar masses online, I highly recommend that you don't. Continue to use the periodic table so that you can get into the practice of how to do it. You'll want your calculator and either your periodic table, or if you haven't printed one out, go ahead and get periodictable.com online. That's the one I'm going to use as we go. So I've just got 4 here to practice. 2 of them come from your worksheet so that you've got a head start. What I'm going to have to know in all of these cases, I'm always going to have to find, and I'm going to star this so that you know, find the molar mass. And any time that we are moving from grams to moles or moles to grams, you have to use the molar mass as your conversion factor. It's like saying 12 inches in a foot, or 36 inches in a yard, or 100 centimeters in a meter. It's a conversion factor. If you want to go from miles per hour, or any of those things, minutes in an hour. So we look at this molar mass conversion to help us. All right, 25.3 grams of water. First thing I'm going to do is find my molar mass of water. So I'm going to do that right over here. And I've got 2 H's, each one at 1.008 grams per mole. I've got 1 oxygen at 15.999. And so I can bring those together for the total, and this is at advanced total, 1.008 times 2 plus 15.999. And we can see we've got a value of 18.015 grams per mole. Now I set up the conversion. Always go with what you're given. 25.3 grams. Always go with what you're given. I'm going to circle it in green so you know that's where I got that from. Then in order to make the conversion, here I'm going to use my molar mass. And I have to set it up to get to what I want and cancel what I've got. So to get to what I want to know how many moles. To cancel what I've got, I want to cancel the grams. So notice I've brought in the molar mass to allow me to get to where I want to go so that I can cancel what I've got. And these units, grams and moles, are very much like your X's and your Y's when you are in math class. But here we work it. So now this is pretty easy because I've just got the math here on the working to do. And so I'm going to go 25.3 divided by, and on my calculator, I can go up and grab the number, or you can use the answer function, or you can type it back in. But there I've got it, and I can see that my answer is 1.4, and I'm just going to cut it off at 1.40 moles. Keep my numbers easy of water. So that is that first example. Let's move quickly through. I've got a lot of grams here of sulfur dioxide, and I know it's dioxide because I have 2 oxygens. So sulfur, I've got 1. Oxygen, I've got 2. If I remember, sulfur was 32.06. And oxygen, they give us the 15.999. So we can combine those. 15.999 times 2 plus 32.06. And math laws say I can go either direction. I know I should have gone 32.06 for you first, but you see that you get the same answer. Let's just double check that. 32.06 plus 15.999 times 2. For all those who want to verify the math, it's still 64.058. The laws of math continue to work for us. And I will say grams per mole. All right. So this is my given. This is my conversion. And I'm headed from the 374.5 grams and convert it out to see how many moles of sulfur dioxide are in that. My conversion factor is 64.058 grams. Again, there's my conversion factor. That's the given for the equation. I can cancel the grams. I do the math. 374.5 divided by, and these are fractions. These are fractions when we do our conversion. So I know I'm multiplying by 1, dividing by 64. Multiply across. And divide down. Treat them like fractions or such. So grab that answer. And I see that my answer should be 5. Now I'm going to round up the 6 so that I've got 5.85 moles. All right, let's go the other way. Again, here's my given. Hydrogen chloride. Now, you may not have done enough with the nomenclature to know what hydrogen chloride is, so you'll have to look it up online when you get problems like that. But it's simply an H with a Cl, and they are balanced because it's H plus 1 and chloride negative 1, so they balance each other out like that. If I had said barium nitrate, you would have to know that the barium is a plus 2 and the nitrate is a negative 1, and so it takes 2 of them. Now, that's another lesson. So hold on, hang on. But I'm going to start. I have to find the molar mass of hydrogen chloride, 1.008. I have to find the molar mass of chlorine. And on the periodic table, I find that as 35.45, which I can do some quick math, and I know that's 36.458. All right. Take my given, 2.35 moles. Make my conversion. Now this time, I am going 2 grams. So my given always starts in the top left, but my conversion, I want to get rid of the moles. So I'm going to put my conversion factor right up here so that 1 mole in 36.458 grams. This way I can cancel the moles and I will find the correct answer in grams. So let's do our math. 2.35. There we go, you can see now. 2.35 times 36.458. And I can see I've got 85 and again, I'm rounding up 7 grams of HCl. All right, one last one to demonstrate for you again, because this has that complicated polyatomic ion thing going on. First thing, of course, I want to convert to, or find the molar mass. So barium, there's 1 of them. On the periodic table, we find that over in our alkaline family, family number 2, and it says it's 137.33 grams per mole. Remember I've got to multiply everything inside here. So 2 times 1, I've got a nitrogen. 2 times 1. So I've got 2 times, the nitrogen comes out to 14.007. And then I've got the oxygens 3 times 2 for a total of 6. Figure this all out. Let's see, 137.33 plus 2 times 14.007 plus 6 times 15.999. There we go, 261.338 grams per mole. Notice when I'm doing my conversions, I do leave all the digits on the calculator. I let that work that way to help me out. All right, so once again, I've got given, conversion factor. Now I'm going to set this up. You may see that this actually looks more like what you've done in a math problem before. 0.75 mole. And I'm going to multiply by the fraction of 261.338 grams for every 1 mole. That might look more familiar to you, and that's definitely a way to go. If that's an easier way to practice these problems, by all means, please practice these problems using the familiar math part. In chemistry, we use these conversion brackets because we set up longer and longer conversions as we go. And I'll show you that. But since we're online and distance learning, it's either option. And next week, when we look at more of these lessons, I'll show you. Hey, it's already set up. I'm not going to give you the math here, let you do that to figure it out, because you've seen it's as easy as punching it into the calculator.